Here we are on number 4, which is one of those well-loved true-false multiple-choice type questions. And the first the instructions are circle the correct statement. And so, statement A, the activated complex must include all the molecules in the rate law for the elementary process. Absolutely. That's how we write the rate law. So in other words, I write the rate law that whatever was on this side is going to be included in this activated complex. These are the reactants which are coming together to form, inevitably we're interested in what happens in the transition state, but it has to include all the reactant molecules that were included in the rate law. Yeah, if that's one of the reactants, yes. So in this case, it has to include all of them. So the activated complex again is all the part between the wells. And so yes. So part A, for part A, is true. Now B, for a statement. The rate law for an SN1 mechanism is 0th order in nucleophile.
True.
That is true. Well, why is that true?
Good question.
Okay. What is the SN1 mechanism?
One-step mechanism?
Well, yeah, it was not a one-step mechanism. It was, yeah, the SN1 is a substitution nucleophilic unimolecular. So the rate determining step in one of these processes is the dissociation of what we call the substrate molecule into a cation and some anion. The leaving group is gone. I've got a cation, and that's the biggest energy step. That's the rate determining step. So then the next step in that two-step mechanism is the attack by the nucleophile on the cation that was generated in the first step. And so, since that's not a rate determining step, the nucleophile enters in a subsequent step, the rate is going to be determined by what? The rate determining step, which is the dissociation. So if I go to measure this reaction, I'm going to note a concentration that depends. It's a first order dissociation process. It's going to be first order in the substrate. And now if I vary the concentration of the nucleophile, what do I see in the rate? What change does that have? None whatsoever. If I change the concentration of the substrate, I see a first order dependence. I change the concentration of the nucleophile in a series of experiments, and I measure the rate of the reaction, and it's independent of the concentration of nucleophile. As long as there's some nucleophile there, it happens, because that second step is a fast step. The first step was the slow step. So that means it's going to be 0th order. When 0th order, the order refers to what in the rate law? The order with a particular species is the
exponent.
The exponent.
Yeah.
Okay, when 0 is an exponent, what's anything taken to 0th power? 1. So we say it's 0th order in the nucleophile. And so that turns out a long conversation to say that's true. So for an SN1, and for this was in that brief stuff we had, the handouts I gave you on SN1 and SN2 mechanisms. We were talking about the organic chemistry part. That was the application of kinetics and organic chemistry that we discussed. And then we had some stuff we talked about with inorganic chemistry and the transition metal chemistry. That would be in that set of handouts, the SN1 and SN2. You might want to know SN1 and SN2 for this test. We'll have a problem later on that's going to deal with SN2. And it's going to be a written one. Okay. So that one's true. And then C, if there's an increase in charge going from reactants, and this wording was not the best. I said going from reactants to activated complex in a process, then the increasing the polarity of the solvent will lower the activation energy. So where I put activated complex, put in transition state. And that would be a better, that would be a clearer question. Because the activated complex is everything between the wells in a reaction. You know, all of this is activated complex. The transition state is the particular arrangement that occurs at the top of the highest energy form as the reaction proceeds and the reaction's progress. Now, having said that, if there's an increase in charge, so if I had, let's say I had neutral reactants, I have neutral substrate, and I have neutral nucleophile, and they're going to form a charged species. In other words, there's going to be charge spread out. The leaving group's going to bear a partial negative charge. Then the incoming group might bear a partial negative charge with a partial positive charge localized at the transition state. Then in that case, there would be an increase in charge going to the transition state. Or it could be one where there's a decrease in charge, where the charge is more spread out at the transition state, in which case there's not an increase in charge, where I had, let's say I had very highly charged reactants. Nucleophile was charged, substrate could be neutral, but a charged nucleophile, and then that charge is spread out in that transition state where there's a partial negative charge on the nucleophile, partial negative charge on the leaving group with a partial positive charge buildup. There would actually be a decrease in charge. The charge is more dispersed and spread out in the transition state. And so in that case, there'd be a decrease in charge buildup. And why is that so important? This goes to the solvents. A polar solvent solvates charged materials. Well, you need a polar solvent to get something to, like a salt to dissolve. And so if it's that the solvation energy is favorable, yeah, it's going to that interaction is going to act like a catalyst insofar as it's going to lower the activation energy for that process. It's going to bring down the energy of that charged species at the transition state. So if there's a charge buildup going to that transition state, increasing the polarity of the solvent will lower the activation energy. And we would see the reaction go faster in more polar solvents. And if I wanted to slow it down, I would lower the polarity of the solvent, use a less polar solvent, and that would increase the activation energy because of a less favorable solvation of that charged species that builds up. Hi.
I have a question.
Hi, how are you doing?
What?
Oh, what is it?
It's an ice lemon drink.
Oh, I love it. Thank you very much.
You're welcome.
Thank you.
Where's mine?
Nice.
That was cool.
Coffee.
Thank you.
High class stuff right there.
That is absolutely delicious. Now, is there an increase in charge in going from an iced coffee? It's true. Yeah. So C, what did I say in C? What was it? Yeah. It will lower the activation energy. I can't do that one with a Tweety or something.
The
Yeah,
Wergy?
it's true. It's very true. So it's true. So I would circle that one. Okay.
So
Is
what's
every-
the right clue out?
Right. Oh, you could wipe pool out if you like. Okay. Okay. So that, I'm gonna have another sip of this. There's the cold part. I've got to read left side, not right. Okay. Any questions on that? Now let's go on to number 5, although there have been some requests. Okay, go and shut.